Welcome to this video on the chapters of the National Electrical Codebook. I'm going to be looking at the 2020 edition here. Okay, so opening first up, we see the contents. I'm going to read off the chapters here, and then I'm going to actually go through the chapters in order, which will make a lot more sense. Okay, so just so we know what we're getting into, we see before chapter 1 there is an introduction. There's Article 90. And we will go over that. There are some good things to go over in there. And it's a good short read. It is only 3 pages, so might as well just read through it. Okay, after that we see Chapter 1 General. I'm just going to name off the chapters for now. We see Chapter 2 Wiring and Protection. Chapter 3 Wiring Methods and Materials. Chapter 4 Equipment for General Use. Chapter 5 is Special Occupancies. Chapter 6 is Special Equipment. Chapter 7 is Special Conditions. Chapter 8 is Communication Systems, and Chapter 9 is Tables. Okay, so first starting off, getting into that intro, and this is just an introduction before Chapter 1, before any of the chapters, and there's some very useful information here. First, we see 90.1 Purpose. A says Practical Safeguarding. If you read through A, B, and C, you'll see that for the most part it is saying that the whole point of the code, of the electrical code, is to ensure safety. And it furthermore goes into saying that the code is not intended as a design specification or an instruction manual for untrained people. Okay, and in their words, the code is the practical safeguarding of persons and property from hazards. This is when arising from the use of electricity, of course. Okay, so that makes sense why the codebook is the way that it is. It is all just to ensure safety. It's not intended for design or instruction. Then we go into 90.2 Scope. This is very important because this talks about what the code covers. You see A, it mentions covered, and it talks about the code covering the installation and removal of electrical conductors, equipment and raceways, signaling and communication conductors, equipment and raceways, and optical fiber cables for the following areas that are public and private, which include buildings and structures, even mobile homes, recreational vehicles, and floating buildings. That's 1. And then we see 2, it talks about parking lots, yards, and then even has carnivals and industrial substations. We see number 3 mentions the installation of conductors and equipment that connect to the supply of electricity. And then we see 4 talks about installations that are being used by the electrical utility. This includes recreational buildings, office buildings, warehouses, garages, machine shops that are not an integral part of the generating plant, substation, or control center. 5 and 6 here in 2020 are gray, so that means it was a new addition to this code. We see installations supplying shore power to ships, marinas. We see 5 mentions installations in marinas and boatyards that supply shore power to ships and watercraft, which includes the monitoring of leakage current. Then we see number 6 mentions installation that is used to export electric power from vehicles to premises wiring, and then it mentions or for bidirectional current flow. Okay, so the whole point of that is now you have a place in the code book where you know where it covers what is actually in the code. This is very important because we see B is not covered. It talks about things that the code does not cover. The first one mentions ships and watercraft other than floating buildings. It also mentions automotive vehicles, aircraft other than mobile homes, and recreational vehicles. We see number 2 talks about mines and self-propelled mobile surface mining machinery, which are of course installations underground, which include the electrical cable needed for that. 3 and not covered mentions railways for generation, transformation, energy storage, transmission, or distribution of power. And then we see number 4 mentions the installation of communication equipment under the exclusive control of communication utilities located outdoors or in building spaces used exclusively for such installations. Okay, I just read off any of those because if any of that pops up in a test question, you're going to have that more familiar now. And now something might click in your brain. You say, okay, I think I know where to find that. Moving on. Okay, 90.5. I'm just going to read the main ones here. We see mandatory rules, permissive rules, and explanatory material. A talks about mandatory rules, and it mentions that these mandatory rules will specifically be required or prohibited and furthermore that they are characterized by the use of the terms shall or shall not. So in other words, when you have to do something, when it is mandatory, they're going to say you shall do this. And then when it is mandatory that you cannot do something, okay, it is in the code that you can't do something, they're going to use the terminology shall not. This shall not be done. B is permissive rules. These are rules that are allowed but not required. These are characterized by the use of the terms shall be permitted or shall not be required. Okay, so that's mainly just what I want to cover in the intro there. Now I'm going to get into Chapter 1, Article 100, definitions. Okay, but first, under scope, we see there's Part 1 of the article, which contains definitions, which are intended to apply wherever the terms are used throughout the code. But there's more than that. There's Part 2, which also contains definitions, but these are applicable to installations and equipment operating at over 1,000 volts. Okay, so when you have certain things operating at over 1,000 volts and you want to find the definition, now you know that's going to be Part 2 of the definitions, which if you don't know that and you're just flipping through the definition section, you might not realize that you're going through 3 different sections of definitions. Okay, so it's really good to understand that. Part 3 contains definitions that are applicable to hazardous, in other words, classified locations. And you'll be using those enough. Okay, we're going to flip forward to Article 110, requirements for electrical installations. We're going to look at Article 110.13, mounting and cooling equipment. We see it talks about mounting electrical equipment, and it says that it shall be firmly secured to the surface on which it is mounted. And then it further mentions that wooden plugs driven into holes in masonry, concrete, plaster, or similar materials shall not be used. Okay, so I've seen that question before. B says cooling. It talks about electrical equipment that needs certain airflow to help it cool down. In their words, electrical equipment that depends on the natural circulation of air and convection principles for cooling of exposed surfaces. These shall be installed in a way so that the room's airflow over such surface is not prevented by walls or adjacently installed equipment. Okay, so you want to have the equipment able to be cooled. It's not backed up against a wall. It doesn't have other equipment crammed right next to it. It's pretty straightforward and obvious, but now you know this is in the codebook. It furthermore talks about equipment that is designed for floor mounting, and it talks about clearance between the top surface and adjacent surfaces, and how it shall be provided to dissipate rising warm air. Okay, we're going to go forward into 110.15, high leg marking. It talks about a 4-wire delta connected system where the midpoint of one of the phase windings is grounded. It mentions only the conductor or bus bar having the higher phase voltage to ground shall be durably and permanently marked by an outer finish that is orange in color. Okay, and there's a little more to that you should probably read. We're going to look at 110.19, light and power from railway conductors. And this is a good one. It mentions that circuits that are used for lighting and power shall not be connected to any system that contains trolley wires that have a ground return. Okay, that might seem kind of random. That is very important. We're going to go into Part 2, 1000 volts nominal or less, 110.26 spaces about electrical equipment. It talks about how access and a working space shall be provided and also maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. We see A talks about working space, and this is for equipment operating at 1000 volts nominal or less. It mentions 110.26 A1, A2, A3, and A4 tell you what is permitted about working space. So we see 1 says the depth of working space. A mentions dead front assemblies. Working space shall not be required in the back or side of assemblies, such as dead front switchboards, switchgears, or motor control centers. B talks about low voltage. By special permission, smaller working spaces shall be required where all exposed live parts operate at voltages that are not greater than 30 volts, root means square, and 42 volts peak or 60 volts DC. Okay, if you don't understand all that, it's not super important. Okay, after that, we were in 1 depth of working space. We see 2 is the width of the working space. Here it talks about when you're in front of electrical equipment and you have a certain width of space in front of that electrical equipment, and how wide does that have to be? and it mentions the width of the equipment or 30 inches, which is greater. So you have a 30-inch minimum, or if the actual equipment's wider than that, then it's going to be the width of the equipment. It furthermore mentions that if you have equipment that has doors and hinged panels, that it must allow for a 90-degree opening. Okay, so like you can imagine, if you had a door, completely is able to open that 90 degrees. Then we see 3 is the height of the working space. Okay, how high does that working space have to be? What are the parameters we're working with? And it first mentions that the working space shall be clear and extend from the grade floor or platform to a height of 6.5 feet. And again, or the height of the equipment, whichever one of these is greater. Okay, so you have a 6.5 foot minimum. Okay, so we'll go over that one more time. We have 1, the depth of the working space. The ace is the dead front, and at the bottom of that does mention where you have rear access required to work on non-electrical parts of the back of enclosed equipment. You have a minimum horizontal working space of 30 inches. So that's non-electrical equipment. I don't know if they're going to talk about that, but that is here in the book. 2 talks about the width of the working space, and you have a 30-inch minimum. That means if you have the width over 30 inches, then you're going to have the width of the equipment. Okay, we have the height of the equipment. We have a 6.5 foot minimum. So if the equipment is 6.5 feet, then we're going to have a 6.5 foot minimum. If the equipment is less than 6.5 feet, we're still going to have a 6.5 foot minimum. But if the equipment is over 6.5 feet, then we're going to take the height of that equipment. Then we see also in the height of the working space, it mentions that within these height requirements in this section, other support structures or equipment such as concrete pads associated with the electrical equipment, either above or below the electrical equipment, shall be permitted to extend not more than 6 inches beyond the front of the electrical equipment. Okay, then still in 110.26, we see D mentions illumination. Here it mentions that all working spaces for electrical equipment, switchboards, switchgear, panel boards, or motor control centers installed indoors shall be provided with illumination. Again, pretty straightforward, but it's in the code. E is dedicated equipment space. Here it talks about equipment that shall be located in dedicated spaces protected from damage, and that includes switchboards, switchgears, panel boards, and motor control centers. Okay, and then under E, and then 1AA, it says dedicated electrical space. And here it's talking about that space that's equal to the width and depth of your electrical space that we're working with that we just talked about, and extending from the floor to a height of 6 feet above the equipment or to the structural ceiling. Whichever is lower, this shall all be dedicated to the electrical installation, okay? And then it furthermore mentions that no ducts, piping, or leak protection apparatuses or other equipment that are foreign to electrical installations shall be located in this zone. Moving on to 110.27, guarding of live parts. A says live parts guarded against accidental contact. Here it mentions that permitted by this code, live parts of electrical equipment operating at 50 to 1,000 volts nominal, they say guarded against accidental contact by approved enclosures or by any of the following means. Okay, and you're going to want to read through those, especially number 4, where we see by elevation above the floor or other working surfaces as follows, and we see different minimum height requirements for certain voltages. Okay, so make sure you highlight those and get yourself familiar with that. 110.28 is enclosure types. Enclosures can be marked with an enclosure type number as shown in table 110.28. Okay, and this is when they mention a certain enclosure with a certain NEMA number, NEMA. You won't find that anywhere here in the code book, interestingly enough, but when they ask you about a NEMA number, you're going to look here at table 110.28 enclosure selection, and you'll see the different types, 3, 3R, 3S. This is a very weird table to use, so make sure you look up a video or you figure out how to use this table properly. Moving on to part 3, over 1,000 volts nominal. Make sure you understand what nominal means. And what nominal means is that it exists as the name only. Okay, we see 110.31 says enclosure for electrical installations. Here it talks about electrical installations that are in vault room or closet, or in areas surrounded by a wall screen or fence, with access to which is controlled by a lock or locks, or other approved means An area like this shall be considered to be accessible to qualified persons only. Okay, and then table 110.31, we see minimum distance from fence to live parts. You have the certain feet distance away from your certain nominal voltages. Okay, moving on to article 110.32, working space about equipment. We'll see it basically talks about what I was mentioning earlier, where we see energized parts that are exposed have the minimum clear working space not less than 6.5 feet high, 3.5 feet wide, or the height/width of the equipment, whichever one is greater. And we'll see it mentions that energized parts that are exposed have the minimum clear working space not less than 6 feet high. Okay, so when they're talking about the height, they're saying that it has a minimum of 6.5 feet. It can be taller. And then for the width, you have a 3 foot wide, or the width of the equipment, whichever one is greater. Okay, so you have to have a 3 foot minimum, and then you're only going to make it a bigger width if your equipment is bigger than 3 feet. Okay, so there's some nuance there. And then it talks about the depth being required in 110.34a, and in all cases, the working space shall be permitted to have that 90-degree opening of doors or hinged panels. Okay, we see 110.33 is entrance to enclosures and access to working spaces. 110.34 is workspace and guarding. We see it talks about measuring the distances from live parts if these live parts are exposed, or you measure from the enclosure front or opening if they are enclosed. We see table 110.34a, which is the minimum depth of clear working space at the electrical equipment. Then we see table 110.34e, elevation of unguarded live parts above working space. Above this, pay attention to see where it mentions under C, locked rooms and enclosures. It says permanent and conspicuous danger signs shall be provided. And it shows you danger, high voltage, keep out, okay? So you have to have that in your locked rooms or enclosures, which contain exposed conductors or live parts operating at over 1,000 volts nominal. Okay, and it says that it shall be kept locked, and then that you have to have that permanent and conspicuous danger sign. Okay, this shall be provided. Okay, moving on, 110.36 circuit conductors. Here you see it mentions where circuit conductors shall be permitted to be installed. 110.40 temperature limitations at terminations. Here it mentions that when you have conductors, they shall be permitted to be terminated on the base of 90 degrees Celsius. Okay, and it mentions that conductors shall be permitted to be based on 90-degree temperature ratings and also ampacity, given in tables 311.60c 67 through table 311.60c 86. Okay, so that might seem kind of crazy, but let's go to one of those tables, 311.60c 67, and we'll see this is talking about things that are triplexed in air. We'll see that it's the similar thing about all these. Table 311.60c 68, triplexed in air. Okay, then moving on, 311.60c 69 is isolated in air. 70 is isolated in air. 71 isolated in air. 72 isolated in air, and then it goes to 73 isolated conduit in air. 74 isolated conduit in air. 76 isolated conduit in air. Okay, so you get the point. But then that goes through 86. Okay, so you're going to see similar things when you move on. Okay, so from isolated conduit in air, we see 3 conductors per electrical duct, 3 conductors per electrical duct. Next one, 1 cable per electrical duct, 1 cable per electrical duct. Next we have conductors directly buried in earth, conductors directly buried in earth. Okay, and it goes all the way to 86, where we're ending on conductors directly buried in earth, where we have many different types: insulated copper, insulated aluminum, 3 conductor cables. Okay, so a lot of things there, kind of crazy. But if you look at those, all you gotta know is you're using 90 degrees unless they tell you otherwise. Okay, moving on, 110.41 inspections and tests. I'm not gonna read everything, but I'm gonna mention some very important things here. We're going to move on to Part 4, tunnel installations over 1,000 volts nominal. Okay, I'm not going to get into that, but now you know where tunnel installations over 1,000 volts nominal are located. Part 5, we see manholes and other electrical enclosures intended for personal entry. Okay, we're moving on to Chapter 2, wiring and protection. Starting with Article 200, use and identification of grounded conductors. Okay, and when they say grounded conductor and they say grounding conductor, these are different. When they're talking about a grounding conductor, they're talking about what you actually think as a ground conductor. Maybe a green insulated wire connected to a green screw on a device, which connects to the metal framing or what is bonded to all the metal equipment in the device. This is a conductor that is grounded. Okay, and why is it grounded? This is because when you're at the service, when you're looking at your service entrance cables that are coming from your power lines, okay, your power line has an A and a B phase with a neutral. There's no ground wire. Okay, so where does your ground wire come from? And if you open up your service panel, or if you've wired a service before, then you know that on the load side of your service terminals, you have an A and a B phase with your neutral, and on that neutral lug, you also have another place where you add your ground wire. This is why it's called a grounded wire, because all your ground goes back to the neutral and it doesn't go into the ground or the dirt like what some people might think. Okay, so when lightning strikes your house and it gets into your electrical system, the purpose of this ground rod is to serve as a purpose for the electricity to escape in a circumstance, like in a circumstance where lightning creates a surge of electricity. So that's why people might think that your ground goes to ground. It is called ground, but it is a bonding system that is bonding your equipment together, that is bonding everything to your panel. But then furthermore, everything is just connected to that load side of the neutral. So that's why it's called a grounded conductor. Of course, after the service, then you have your ground now because you tapped off a ground from that load side. Okay, so now you're working with an actual ground wire, ground conductors, and you have a ground bar, and you also have a neutral bar, and that's why you don't put the screw in your neutral bar. And this is why in a modern circumstance where you have your main breaker on the service, then your panel that is inside maybe your garage is considered actually a sub panel, where you have your neutral bar and you have that ground screw which is removed. You do not have a ground green screw in your neutral bar of your panel. If you do, then you should have a main breaker at that panel. Okay, so again, if you do not have that main breaker, then it's going to be considered a sub panel. You want that ground screw removed, and this is very important. Okay, Article 200.4, neutral conductors. We have A, installation, B, multiple circuits. Article 200.6, means of identifying grounded conductors. A says sizes that are 6 AWG or smaller, and it mentions the following means of identification. And of course, this is the insulation. Okay, so you can have a continuous white outer finish, that is 1. 2 is a continuous gray outer finish. 3 is 3 continuous white or gray stripes, which are along the conductor's entire length. This is allowed on other than green insulation, okay? Because again, green is going to mean grounding, and we're talking about grounded, we're talking about neutral. Okay, B says sizes 4 AWG or larger. And again, we have the following means of identification, which of course is the insulation. 1 is a continuous white outer finish. 2 is a continuous gray outer finish. Okay, same thing there. And then 3 continuous white or gray stripes, which are along the entire length of the conductor other than green insulation. On other than green insulation. And then we see 4 talks about at the time that you're installing it, by a distinctive white or gray marking at the termination. And it furthermore says that the marking shall encircle the conductor or insulation. Moving on, Article 200.7, use of insulation of white or gray color or with 3 continuous white or gray stripes. Article 200.9, means of identification of terminals. We see that you want the terminals for the neutral to be substantially white or silver. You'll be used to this if you're used to installing things. Even if you look at an outlet and you look at the neutral screws, they're normally going to be silver in color. And then for the hot, it's going to be brass colored. And then generally for the ground, you're going to have a green screw. Here's a random tip, and that is that a number 1 square drive often works perfectly for the screws in devices such as switches or outlets, and actually grips it a lot nicer, and you can torque your screw gun 1 or twice, and you can make sure that it's really tight. Okay, so we see B, receptacles, plugs, and connectors. Again, identification shall be white or silver, okay, just like I was mentioning. It also says or by the word white or the letter W. Okay, so if you're looking at a dryer plug, a lot of times you'll see a W and you'll see an X, Y, and then a G. The X and the Y are going to be the different phases of the terminals, which we think of as A and B. But then you have your ground and you have your neutral. Okay, and I have a funny story about this. And that is because, you sometimes work with some guys that are not the brightest. And this one guy, he'd been working for so many years and he kept making mistake after mistake after mistake. And he kept trying to point at me and saying, look at what I'm doing and look how slow I am. But he kept making these bad mistakes that would sometimes cause half a day of trying to figure out what's going on, breakers tripping, and he just sloppily put a switch and there's a ground touching a hot conductor or something out of laziness half the time. Okay, but what happened this time probably was still lazy, but it was very dangerous. Okay, so we were trimming a house, what it's called. You have the rough-in stage where you install the wires, they sheetrock, they paint everything, and then you have what they call the trimming stage, which is where you actually install all the outlets and switches. This is at least how we would do it, and then we would put the cover plates on it after that. Okay, that's the trim. So we're doing trim, we're installing the switches, the outlets, all the things you need for a house to make it work properly. And I'm pretty sure the boss did this on purpose, and he would have certain people working on certain things in each house, okay? So me being the new guy, I was probably just doing all the 15 and 20 amp outlets and then all the switches around the house. He was doing some of the more complex stuff that for me would probably take a little longer. He could do it a lot quicker. Okay, and one of the things was he was installing all of the dryer plugs in each of the units. Long story short, the day comes when the people have to install the appliances. The appliance guys come with the dryer. They got the cord for the dryer, they plugged it in the dryer plug, and in their words, flames shot up the wall 10 feet high, literally charring the wall. And I guess the appliance guys stopped what they were doing and said, hey, we're not coming back till this gets thoroughly inspected. I can imagine why. And I think that guy is really lucky that no one died, okay? Because he's done some other stupid shit that I just think, oh my gosh, you should not be doing that. Do not play around, do not kid with electricity. It's not something to kid around with. Okay, this was very dangerous. We had to go back and we had to figure out what's going on. I don't remember exactly how the plug was wired, but I do remember one specific thing, and that was that one of the 50 amp 120 volt legs was going into the ground terminal, okay, where you're supposed to put a ground wire, like I was saying, which is bonding everything. So it bonds all the metal on the entire dryer, okay? And it's kind of a good thing that it exploded in flames, because if it didn't explode in flames, he would have put in 50 amp 120 volts on where the ground's supposed to go, which means the entire metal dryer probably would have been electrified. Someone would have touched it. They probably would have died, long story short. Okay, so don't kid around with it. And if you're installing dryer plugs or something, well, make sure you have a light. Make sure you see what you're doing. His excuse was that he's done it so many times, he just knew how to do everything, and that this time they created a new style of dryer plug, and that was the reason. It wasn't his fault. Okay, of course, it wasn't his fault at all. But you can see where that basically could have changed his life completely if he ended up killing someone, because if you make an accident, the law doesn't care if you did something on accident. You still did something. Okay, I'm going to finish up Article 200 with 200.11 polarity of connections, where it just mentions that if you have grounded conductors, where it mentions that no grounded conductors shall be attached to any terminal or lead, so that it reverses the designated polarity. Article 210, branch circuits. We see 210.4 multi-wire branch circuits, B, disconnecting means, and then it talks about each multi-wire branch circuit and how it shall be provided with a means that will simultaneously disconnect all ungrounded conductors, and this is at the point where the branch circuit originates. Okay, moving on, 210.6 branch circuit voltage limitations. A, occupancy limitation. Here it says, in a dwelling unit and guest room or guest suite of hotels, motels, or similar occupancies, the voltage shall not exceed 120 volts nominal between the conductors that supply the terminals in following things. It talks about luminaires, loads that are cord and plug connected loads, 1440 volt amperes nominal, or less than a quarter horsepower. Okay, 210.8 ground fault circuit interrupter protection. A dwelling unit, we see it mentions all the locations that you have to have a ground fault circuit interrupter in a dwelling unit. Okay, this includes 1 bathrooms, 2 garages, and also accessory buildings that have a floor located at or below grade level that is not intended as a habitable room. And then 3 is outdoors. Okay, so outdoor plugs, of course, you need the first one to have that GFCI, so they're all GFCI protected. 4 crawl spaces at or below grade level. 5 is basements. 6 is kitchens. 7 sinks. 8 boathouses. 9 bathtubs or shower stalls. 10 laundry areas. 11 indoor damp and wet locations. Okay, B is other than dwelling units. I'm not going to go over that right now because I'm in the residential section of my YouTube channel at the moment. We see C, crawl space lighting outlets. GFCI protection shall be provided for lighting outlets not exceeding 120 volts installed in crawl spaces. Okay, then 210.11 is very important, the branch circuits required. And A says the number of branch circuits. Here it says that the minimum number of branch circuits shall be determined from the total calculated load and the size or rating of the circuits used. And then we go over to C, it talks about dwelling units. If you've done some load calculations, you know some of this, but this is very important because it talks about the actual branch circuits that you need in a dwelling unit. Number 1 is small appliance branch circuits, and it mentions in addition to the number of branch circuits required by other parts of this section, you need 2 or more 20 amp small appliance branch circuits, and these shall be provided for the receptacle outlets. 2 is laundry branch circuits. You need at least 1 additional 20 amp branch circuit. 3 bathroom branch circuit. You need 1 or more 120 volt 20 amp branch circuit. Garage branch circuit. You need at least 120 volt 20 amp branch circuit. 210.12 arc fault circuit interrupter protection. A dwelling units. All 120 volt single phase 15 and 20 amp branch circuit supplying outlets or devices that are installed in dwelling units, family rooms, kitchens, dining rooms, living rooms, parlors, libraries, dens, bathrooms, recreation rooms, sunrooms, hallways, closets, laundry areas, or similar locations shall be protected by any of the means in 210.12A1 through 6. Okay, and moving on to part 210.18 rating. It talks about the rating for other than individual branch circuits and that they shall be 15, 20, 30, 40, and 50 amperes. Okay, so those are your usual branch circuits, otherwise thought of as your circuit breakers that are going to give you your branch circuits. Okay, 210.19 household ranges and cooking appliances. We see it says ranges of 8 3/4 kilowatts or more, the minimum branch circuit rating shall be 40 amperes. Okay, then exception number 1 talks about conductors that are tapped from a branch circuit that are not exceeding 50 amperes that supply electric ranges. Wall-mounted electric ovens. Again, we see exception number 1 talks about conductors that are tapped from a branch circuit not exceeding 50 amperes supplying electric ranges. These shall have an ampacity of not less than 20 amperes and shall be sufficient for the load served. We see 210.21 outlet devices, and then table 210.21b2, which is the maximum cord and plug connected load to receptacle. We see another table on the next page, table 210.21b3, receptacle ratings for various size circuits, and then table 210.24, summary of branch circuit requirements. Part 3 gets into the required outlets that you need. 210.52 dwelling unit receptacle outlets. A is general provisions. In every kitchen, family room, dining room, living room, parlor, library, den, bedroom, sunroom, recreation room, or similar area of a dwelling unit, receptacle outlets shall be installed in accordance with 210.52A1 through A4. We see 1 talks about spacing. Receptacles shall be installed so that no point measured horizontally along the floor line of any wall space is more than 6 feet from a receptacle outlet. 2 is wall space. As used in this section, a wall space shall include the following. Any space that is 2 feet or more in width, including the space that is measured around corners, and unbroken along the floor line by the doorway and similar openings. 2. The space occupied by fixed panels and walls excluding sliding panels. 3. The space afforded by fixed room dividers such as freestanding bar-type counters or railings. Okay, then we get into actually 3 floor receptacles. Receptacle outlets that are in or on floors shall not be counted as part of the required number of receptacle outlets that are located within 18 inches of the wall. B is small appliances. Talks about your 2 or more 20 amp small appliance branch circuits that are required in your kitchen. And it mentions that they shall serve all wall and floor receptacle outlets covered by 210.52a, all countertop outlets covered by 210.52c, and receptacle outlets for refrigeration equipment. Okay, we have exception number 1 and exception number 2. Exception number 2 says a receptacle outlet that serves a specific appliance shall be permitted to be supplied from an individual branch circuit rated 15 amps or greater. Okay, so let's say you have a dedicated receptacle outlet, or what you might call a home run to an outlet for a microwave. It's saying that must be rated 15 amps or greater. Okay, number 2 says no other outlets, and it talks about how the 2 or more small appliance branch circuits shall have no other outlets. Okay, and I'm mentioning this because you have exception 1 and exception 2. Exception 1 says that a receptacle installed solely for the electrical supply and support of an electrical clock in any of the rooms specified in 210.52b1 are allowed. That is your exception. And that is off your small appliance branch circuit. Okay, so you can have a dedicated outlet that's used for powering and supporting a clock. And then exception 2 is receptacles that are installed to provide power for supplemental equipment and lighting on gas-fired ranges, ovens, or counter-mounted cooking unit. Okay, 3 kitchen receptacle requirements. C, countertops and work surfaces. In kitchens, pantries, dining rooms, breakfast rooms, and similar areas of dwelling units, receptacle outlets for countertop work surfaces that are 12 inches or wider shall be installed in accordance with 210.52c1 through c3. Okay, so 1, wall spaces. Receptacle outlets shall be installed so no point along the wall line is more than 24 inches measured horizontally from a receptacle outlet in the space. Okay, remember, this is talking about your countertops and work surfaces in kitchens, breakfast rooms, dining rooms, and pantries. 2, we have islands and peninsular countertops and work surfaces. We see A, we need at least 1 receptacle to be provided for the first 9 feet of the countertop or work surface, and a receptacle outlet shall be provided for every additional 18 feet of the countertop or work surface. Okay, but it's really weird, but what it's saying is if you have an island up to 9 feet, then you need at least 1 outlet. And then when that gets an additional 9 feet, which is going to be a total of 18 feet, and then every additional 18 feet from there, you're going to need another outlet. Okay, so it's kind of weird how they word that there, just like everything else in the code book. But after you read this a million times, you wouldn't even want to change anything in here. Okay, B, at least 1 receptacle outlet shall be located within 2 feet of the outer end of a peninsular countertop or work surface. Okay, so when you're walking to your kitchen and you're looking at your kitchen, you're not inside your kitchen, you're outside of it, and you see the end of an island. If there's an island there, okay, you want a plug facing you, and it has to be 2 feet down from the actual island. Okay, and you want to make sure that if you're doing new construction and you have an island that doesn't have the slab on it yet, okay, doesn't have the top on it yet, you need to accommodate for that, okay? You can F yourself up if you do something and you don't accommodate for that, because you're going to be measuring from the slab. Just like when you're thinking about doing your lighting fixtures above your island as well, always think about that slab. Okay, and hopefully you're working with wood, so you just have to cut wood, or hopefully the cabinet people cut it for you. And hopefully it's not granite or something. No one likes cutting a giant thick piece of granite. It's sketchy. You don't want to F anything up. And it creates this horrible, probably definitely toxic, plastic smelling gas. That's just horrible. We see 3 talks about receptacle outlet locations. D talks about bathrooms. At least 1 receptacle outlet shall be installed in bathrooms within 3 feet of the outside edge of the basin. In no case shall the receptacle be located more than 12 feet below the top of the basin or basin countertop. E. Outdoor outlets. Under 1 family and 2 family dwellings. At grade level, at least one receptacle outlet readily accessible from grade and not more than 6.5 feet above grade level shall be installed at the front and back of the dwelling. Okay, so you normally know this as your outside plugs. When you go outside the front door, when you go outside the back door, you have to have that plug. And it has to be not more than 6 feet above grade level. F. Laundry areas. In a dwelling unit, at least one receptacle outlet shall be installed in areas designated for the installation of laundry equipment. You have exception 1 and exception 2. G. Basements, garages, and accessory buildings. Need one receptacle outlet installed for the areas provided in 210.52 G1 through G3, which is garages, accessory buildings, and basements. H is hallways. In dwelling units, hallways of 10 feet or more in length shall have at least one receptacle outlet. I is foyers. Foyers that are not a part of a hallway in accordance with 210.h and that have an area that is greater than 60 feet squared shall have a receptacle located in each wall space 3 feet or more in width. 21.60 Guest rooms, guest suites, dormitory units, and similar occupancies. A. General. B. Receptacle placement. Then you have 210.62 show windows. 210.63 equipment requiring servicing. A 125 volt single phase 15 or 20 amp receptacle outlet shall be installed at an accessible location within 25 feet of the equipment. Specified in 210.63a, which is heating, air conditioning, and refrigeration equipment, and then B is other electrical equipment. 210.65 is meeting rooms. Each meeting room of not more than 1,000 square feet in other than dwelling units shall have outlets for non-locking type 125 volt 15 or 20 amp receptacles. You have B receptacle outlets required, 1 receptacle outlets in fixed walls, 2 floor outlets. 210.70 is lighting outlets required. A. Dwelling units. B. Guest rooms or suites. And C. All occupancies. We're moving on to Article 215, feeders. 215.2 minimum rating size, 1 general. And under A, we see it talks about where a feeder supplies a continuous load or any combination of continuous and uncontinuous load shall have an ampacity not less than the non-continuous load plus 125% of the continuous load. 215.5 diagrams of feeders. 215.10 ground fault protection of equipment. Moving on to Article 220 branch circuit feeder and service load calculations. Okay, now I have a whole video about this. So I'm just going to tell you to look at my residential load calculations video. I go over everything that is in this article section of the code book that goes over load calculations for residential units. Okay, moving on to Article 225, outside branch circuits and feeders. From this point on, I'm going to be reading the main articles that are in each chapter, and I'm not going to go through much more than that. I wanted to go through some stuff in the beginning because the beginning of the code book is often not considered as much as the rest of it is. Okay, we're very familiar with most of the rest of the code book, but in the beginning, there's a lot of important stuff there that people tend to overlook. Okay, so I wanted to go over that more in depth. It's going to get a lot more efficient now, and I'm just going to go over the main things in each chapter. We're moving on to Article 230, which is services. Article 240, which is overcurrent protection. We see Article 240.21. This is the beginning of Part 2, location, and we see it's talking about taps and transformer secondary conductors. Article 242 talks about overvoltage protection. We often think of overcurrent protection like a breaker, OCPD, an overcurrent protection device. In this case, we're looking at an overvoltage protection. In other words, a surge protection device, an SPD. Moving on to Article 250, which is grounding and bonding. A really good article to go over. Article 250, Part 3, grounding electrode system / conductor. Table 250.66, grounding electrode conductor for alternating current system. Okay, now we're going to go back. I forgot to mention a really important table, and that is Table 240.6a, which tells you your standard ampere rating for fuses and inverse time breakers. In other words, when you want to find out your breaker size, here are the numbers that you can work with. You can have a 15, 20, 25, 30, 35, 40, and you can see the list goes on. So there you can see the numbers that you're able to use for your breakers. We're going to move on to table 250.102C1, grounded conductor, main bonding jumper, system bonding jumper, and supply side bonding jumper for alternating current systems. Then we're going to go over to table 250.122, minimum size equipment grounding conductors for grounding raceway and equipment. Okay, and that leads us into chapter 3, wiring methods and materials. Article 300 is the general requirements for wiring methods and materials. Table 300.5 is the minimum cover requirements. Here you can see they talk about locations. The first one is all locations that aren't specified below. Below that we have in trench below 2 inches thick of concrete, under a minimum of 4 inches of thick concrete exterior slab, under streets, highways, roads, alleys, under 1 and 2 family dwelling driveways. Okay, so the list goes on. You have certain specific locations for where you're burying conductors, and you have certain columns. Column 1, you have direct burial of cable or conductors. Column 2, you have rigid metal conduit or intermediate metal conduit. Column 3, you have non-metallic raceways listed for direct burial, and the list goes on. Article 310 is conductors for general wiring. Okay, we have table 310.15b1. This is the ambient temperature correction factors based on 30 degrees Celsius, which is 86 degrees Fahrenheit. Okay, and you're going to want to highlight the 90-degree column there. We see table 310.15b2, ambient temperature correction factors based on 40 degrees Celsius, which is 104 degrees Fahrenheit. Okay, moving on, we have table 310.15c1, which is the adjustment factors for more than 3 current carrying conductors. And you see you have your percentage, your adjustment factor. Okay, we have table 310.16, the ampacities of insulated conductors with not more than 3 current carrying conductors. Okay, so that's why then you have the table for the more than 3 current carrying conductors I mentioned right before this. This is kind of funny because if you know from the NEC 2017, then this was called table 310.15b16. Okay, instead of all that madness, now they just turned it into table 310.16, which is actually what it was before NEC 2017. Kind of crazy. Moving on to table 310.17, which is ampacities of single insulated conductors in free air. This is much less commonly used than table 310.16, as well as the other tables after this as well. We're going to go into article 311, which is medium voltage conductors and cables. It's very good to know that if they mention medium voltage, then you're in article 311. We see the thickness of insulation with table 311.10b and c. We see the minimum size of conductors with table 311.12a. Okay, another really important table 312.6a, the minimum wire bending space at terminals and minimum width of wire gutters. Then table 312.6b, the minimum wire bending space at terminals. Then table 314.16a and also b are very important tables. A, you have metal box sizes, and B, you have the volume allowance required per conductor. I do have a video on both of these, and be sure to check those out. Those will be linked in the description below. Okay, and then article 314.27 outlet boxes. A, boxes at luminaire or lamp holder outlets. 1, vertical surface outlets, very important. Boxes used at luminaire or lamp holder outlets in or on a vertical surface. Okay, and here it mentions that boxes that are used at luminaire or lamp holder outlets shall be marked on the interior of the box to tell you the maximum weight of the luminaire that is permitted to be supported by the box, other than 50 pounds. Okay, an exception, a vertically mounted luminaire or lamp holder weighing not more than 6 pounds shall be permitted to be supported on other boxes or plaster rings. Okay, but here's very important, number 2, ceiling outlets. Boxes shall be required to support a luminaire weighing a minimum of 50 pounds. A luminaire that weighs more than 50 pounds shall be supported independently of the outlet box. We have pole and junction boxes and conduit bodies. A, minimum size. 1, we have straight poles. The length of the box or conduit body shall not be less than 8 times the metric designator trade size of the largest raceway. Angle or U-poles shall not be less than 6 times the metric designator trade size of the largest raceway in a row. Okay, moving on to Article 332, we have mineral insulated metal sheathed cable type MI. Okay, and we see a lot of different types of cable here, and that goes all the way to Article 340, where we have the cable type UF. And then Article 342, we get into conduit types. That goes through Article 356 with type LFNC conduit. Then we get into Article 358, which then we have types of tubing. Tubing goes till Article 362, where then we have Article 366 auxiliary gutters. Article 368 busways. Article 370 cable bus. Article 372, cellular concrete floor raceways. Article 374, more raceways. And then Article 376, we have wireways. Article 378, we have another wireway. Article 380, we have a multi-outlet assembly. Article 382, non-metallic extensions. Article 384, strut-type channel raceway. The raceways go till Article 390, where we have underfloor raceways. Then we get into Article 392 with cable trays. Article 392, low voltage suspended ceiling power distribution systems. Okay, past this we get into Article 394, concealed knob and tube wiring. Okay, so that's where that is. Article 396, messenger supported wiring. Article 398, open wiring on insulators. And Article 399, outdoor overhead conductors over 1,000 volts. Okay, and now Chapter 4, equipment for general use. We see the table 400.4, flexible cords and flexible cables. That's an important one. Okay, so familiarize yourself with that. That goes along with table 400.5A1. And then we have 400.5A2, the ampacity of cables SC, SCE, SCT, PPE, G, GGC, and W. Table 400.5A3, the adjustment factor for more than 3 current carrying conductors in a flexible cord or flexible cable. Getting into Article 400.4, which is switches. 400.6, which is receptacle cord connectors and attachment plugs, caps. Article 406.12, tamper-resistant receptacles. Article 408, switchboards, switchgear, and panel boards. 408.3, we see the support and arrangement of bus bars and conductors. E, bus arrangements, 1 AC phase arrangement. We see in here it mentions that the B phase shall be the phase having the higher voltage to ground on the 3-phase 4-wire delta connection systems. G, minimum wire bending space. The minimum wire bending space at terminals and minimum gutter space provided in switchboards, switchgear, and panel boards shall be required in 312.6. Table 408.5, clearance for conductors entering bus enclosures. 408.8, reconditioning of equipment. If equipment has been damaged by fire, products of combustion, or water, it shall be specifically evaluated by its manufacturer or qualified testing laboratory prior to being returned to service. Okay, A, panel boards. We see it says panel boards shall not be permitted to be reconditioned. But then after that, it says this shall not prevent the replacement of a panel board within an enclosure. Furthermore, in the event that the replacement has not been listed for the specific enclosure, and if the available fault current is greater than 10,000 amps, the completed work shall be field labeled. We're just going to get into some important stuff here in this chapter. Part 2, switchboards and switchgear. 408.18, clearances, A, from ceiling. Totally enclosed switchboards. Other than a totally enclosed switchboard or switchgear, there shall be the provided space of not less than 3 feet at the top of the switchboard or switchgear, and any combustible ceiling unless a non-combustible shield is provided. Okay, part 3, panel boards. 408.36, overcurrent protection. Panel board shall be protected by an overcurrent protective device. This shall have a rating not greater than that of the panel board. And this overcurrent protective device shall be located within or at any point on the supply side of the panel board. The exception number 1, a panel board constructed or wired under this exception shall not contain more than 42 overcurrent devices. In this circumstance, a 2-pole breaker will count as 2 and a 3-pole breaker will count as 3 overcurrent devices, respectively. We also see exception number 2. Then under that we have A, snap switches rated at 30 amperes or less. These shall have an overcurrent protection of 200 amperes or less. Backfed devices shall be secured in place by an additional fastener. This is one that requires other than a pull to release the device from the mounted means on the panel. Okay, and then we can see table 408, minimum spacing between bare metal parts. And then we have article 409, industrial control panels. We can see part 2, installation right away, and then part 3, construction specifications, 409.102, bus bars and conductors. B, phase arrangements. The phase arrangement on a 3-phase horizontal common power and vertical bus shall be ABC from the front, back, top, bottom, or left, right, as viewed from the front of the industrial control panel. And again, the B phase shall be the phase having the higher voltage to ground on the 3-phase 4-wire delta connected systems. Article 410, luminaires, lamp holders, and lamps. Okay, 410.2 definition. Clothes closet storage space. The volume bounded by the sides and back closet walls and planes extending from the closet floor vertically to a height of 6 feet or to the highest clothes hanging rod and parallel to the walls at a horizontal distance of 24 inches from the sides and back of the closet walls, respectively. Okay, we see in part 2 luminaire locations. 410.10 luminaires in specific locations. A, wet and damp locations. Okay, we see D, bathtub and shower areas. No part of the luminaire, lighting track, pendant, or ceiling suspended paddle fan shall be located within a zone measured 3 feet horizontally, 8 feet vertically from the top of the bathtub. Okay, so we see that includes the paddle fans. So when it mentions paddle fans and we want to know the height in a bathroom, we're going to know where to find that. And we're going to find the support for the paddle fan in a different location, because remember, we're in the luminaire section right now. 410. Okay, and then we see number 2, it says luminaires located where subject to shower spray shall be marked suitable for wet locations. And you see above this mentions that it also includes if you're within that 8 feet parameter that they said that you have to be outside of. So if you're within that, then it's also going to have to be marked suitable for damp locations or marked suitable for wet locations. 410.14 luminaires in show windows. Chain-supported luminaires in a show window shall be permitted to be externally wired. 410.16 luminaires in clothes closets. C, location. The minimum clearance between the luminaires installed in clothes closets and the nearest point of a clothes closet storage space shall be as follows. Okay, we see 1 through 5. Of course, you're not going to memorize these, but you're wanting to highlight these because you see 12 inches for surface-mounted incandescent or LED, for example. That's number 1. And then you see you have surface-mounted fluorescent, recessed incandescent or LSD, recessed fluorescent, and fluorescent LED. So you're going to want to highlight those so you can read that quickly. And also the spacing that you're allowed to do. So the 6 inches, 12 inches, okay? Okay, part 4, we see luminaire supports. This one is important. A, general, luminaires and lamp holders shall be securely supported. A luminaire that weighs more than 6 pounds or exceeds 16 inches in any dimension shall not be supported by the screw shell of the lamp holder. Okay, so when they ask you what's the maximum weight that you can support from the screw shell of a lamp holder, now you're going to know where to find that. It's not more than 6 pounds or not more than 16 inches in any direction. So that means it could even be a 16-inch flush light, or it could be a 16-inch tall light from the ceiling down. Whatever it is, 16 inches in any direction, or 6 pounds. So make sure you highlight or, because if it's one of either of those, then you're not going to be able to support it by that screw shell. Okay, under B1, you're also going to want to read that. And then exception number 1, exception number 2, 410.36 means of support. B, suspended ceilings. Luminaires shall be securely fastened to the ceiling framing members by mechanical means such as bolts, screws, or rivets. Okay, we have article 411, low voltage lighting. Article 422, appliances. 424, fixed electric space heating equipment. 430, motors, a very important article. Table 430.52 is the maximum rating or setting of motor branch circuit, short circuit, and ground fault protective devices. We have table 430.247 where we have the full load current amps for direct current motors. We go to the next page, we have the FLC and amps for single phase AC motors. So now we're in AC. And then we have 430.249, not very commonly used, two-phase alternating current motors, 4-wire. You're basically going to use 430.248, the FLC for single-phase AC, and then here 430.250, the FLC for three-phase alternating current motors. Here you'll see it mentions it has induction type squirrel cage and wound rotor amps. Okay, so you have the squirrel cage there, you have the wound rotor, and those are induction type. Next you see you have synchronous type, unity power factor amperes. Okay, you have some more tables and we get into article 440, air conditioning and refrigeration equipment. Then we have article 450, transformers and transformer volts, including secondary ties. Article 490, equipment over 1,000 volts nominal. Okay, now we're in chapter 5, hazardous or classified locations. Classes 1, 2, and 3, divisions 1 and 2. Okay, and make sure that you know that these are the hazardous or classified locations when they're talking about class 1, 2, and 3, division 1 and 2. This is different than class 1, 2, and 3 remote control signaling and power limited circuits that you're going to find in article 725. Okay, so make sure that you know the difference between those. We have article 501, class 1 locations, article 502, class 2 locations, article 503, class 3 locations, and article 504, intrinsically safe systems. Article 505 is zone 0, 1, and 2 locations, so when you're wanting to find the zone. Article 510, hazardous or classified locations that are specific. Article 511, commercial garages, repair and storage. Article 513, aircraft hangars. Article 514, motor fuel dispensing facilities. Article 515, bulk storage plants. Article 516, spray applications, dipping, coating, and printing processing using flammable or combustible materials. Article 517, healthcare facilities. Article 518, assembly occupancies. Article 520, theaters, audience areas of motion picture and television studios, performance areas, and similar locations. Article 522, control systems for permanent amusement attractions. Article 525, carnivals, circuses, fairs, and similar events. Article 530, motion picture and television studios and similar locations. Article 540, motion picture projection rooms. Article 545, manufactured buildings and relocatable structures. Article 547, agricultural buildings. Okay, so we see a lot of different buildings, structures, and rooms that are going to be used for things like filming a movie, filming a commercial, or even things like agricultural buildings as we see here. 547. Then 550, mobile homes, manufactured homes, and mobile home parks. Okay, and if you ever get confused and you want to find these, they have the keyword index that you can buy, but in fact that does not have everything in it. So if you go to in the beginning where it has the chapters, if you see chapter 5 special occupancies, you'll see everything listed out for you, and it's not going to be in alphabetical order, but it'll be in order of the code book, so you can use that as a method for scanning for that. And as you can see, chapter 5 isn't a huge chapter, so when you want to find those special occupancies, you can just scan through the beginning of the code book where it shows you the chapters. And then article 555, we have marinas, boatyards, floating buildings, and commercial and non-commercial docking facilities. Article 590, temporary installations, and that brings us to chapter 6, special equipment. We see Article 600, electric signs and outline lighting. This is something that's used a lot, so it's good that they put this here in the beginning. And then you'll also see if you go to Article 620, we have elevators, dumbwaiters, escalators, moving walk platform lifts, and stairway chair lifts. Okay, so here's where we also have elevators. But not only that, we have Article 625, Electrical Vehicle Power Transfer System. Okay, so here's for your EV vehicles. Article 645, Information Technology Equipment. Article 646, Modular Data Centers. Here's a really important one, Article 680, Swimming pools, fountains, and similar locations. So spas, hot tubs, stuff like that. Article 690, Solar Photovoltaic PV Systems. Article 694, Wind Electric Systems. Okay, so when you think of windmills and stuff like that. Article 695, Fire Pumps. And now that brings us to Chapter 7, Special Conditions. Here's where we have Article 700, Emergency Systems. Article 702 is Optional Standby Systems. Then we have Article 706, where we have Energy Storage Systems. Article 708, Critical Operation Power Systems, COPS. Article 725, Class 1, Class 2, and Class 3, Remote Control Signaling and Power Limited Circuits. Here, remember, get yourself familiar with the difference between Class 1, 2, and 3, Remote Control Signaling and Power Limited Circuits, and your hazardous Class 1, 2, and 3 locations. Article 727, Instrumentation Tray Cable Type ITC. Article 728, Fire Resistive Cable Systems. Article 750, Energy Management Systems. Here's a very important one, Article 760, Fire Alarm Systems. We'll see Part 2 is the Non-Power Limited Fire Alarm, NPLFA, circuits. Okay, there's a lot of important stuff throughout here. And then Article 770, Optical Fiber Cables. That brings us into Chapter 8, Communication Systems. Article 800, General Requirements for Communication Systems. Article 805, Communication Circuits. Article 820 is Cat 5. It is called Community Antenna Television and Radio Distribution Systems. Article 840, Premises Powered Broadband Communication Systems. And that brings us into Chapter 9. And I have a video on Chapter 9 overview. I'll leave that in the description. I go over some very important things here in Chapter 9, as well as the tables. And I have videos on how to use those as well. Okay, so we see Chapter 9. We have tables 1 through 12. You're going to use Table 4 to find out how much space you can fill in certain conduit, and you're going to be using square inches. You're typically going to be using the over 2 wire section, although you see other sections as well. The 60% section is only for conduit or tubing nipples that do not exceed 24 inches, as mentioned in the beginning where it says Notes to Tables number 4. That is mentioned in my Chapter 9 video. Then we get into Table 5. You're going to use this to find the size of certain conductors. So you have a number 10 THWN wire. Now you can see the square inches for that. We move on to Annex C. This is very important. You're going to use this table when you have multiple conductors that are all the same size. So you're going to know the type of conductor you're working with, the gauge of conductor that it is, and then you also know the number, and they're going to be all the same size. So let's say we have 16 number 12 THHN conductors, and we want to fit that inside an EMT conduit. We see that would fit a 1/2 inch EMT conduit here in Annex C. I chose EMT because that's the first one, but you're going to want to go back on the first page and see that it tells you a table and page. So it tells you where all these are listed on each page. Make sure to use this, because as you see, some of them are separated by a pretty big number. It starts on page 730, it ends on page 814. So you're not going to want to flip almost 100 pages trying to find what you're looking for. You're going to want to go to this front page. If you have EMT, you see that's page 730. But if, let's say, you have PVC Schedule 40, then you're on page 794. Okay, so that's over 60 pages after it. You're not going to want to flip through all that. After Annex C, we get into Annex D. Here we have examples. Selection of conductors, voltage, fractions of an ampere, power factor, ranges, SI units. Example D1A, one family dwelling. So they give you a load calc question, and they solve it for you and everything, and they show you how to do it. Example D1B, one family dwelling. You have another load calculation for a one family dwelling. And then you have much more examples of load calculations here in Annex D. It gets all the way into multifamily dwellings, the feeder neutral, earth feeder, minimum size feeder required for each dwelling unit. Okay, and then it even gets into example D7 sizing of service conductors for dwellings. Okay, and there's a lot of examples here in Annex D. After this, it gets into informative Annex E, types of construction, and then you have informative Annex G, supervisory control and data acquisition, SCADA. Then informative Annex H, administration and enforcement. Informative Annex 1, recommended tightening torque tables from UL standard 486A to 486B. Informative Annex J, ADA standards for accessible design. Okay, and after that we get into the index. And what's really nice about an index is that it is in alphabetical order, and it's going to tell you the exact article to find everything. Okay, so that's it for this video. I could have made this an extremely long video going over a bunch of things throughout the book, but that would have been so boring, it would have been hard to pay attention to. Okay, so make sure if you're going to take a test, you find practice tests and you take those, because that's actually going to lead you to finding all these answers in the book. That's why I have so many random things here to tell you, because I've answered a bunch of questions and I have a bunch of things highlighted because of that. And then it also associates a question with how you find it in the book, instead of just reading it, which is really boring. Okay, so the main thing you should get out of this is that the chapters are listed all in the front. You can read through those. You should know the difference between each chapter. And also there's some very important stuff that you find in the very beginning and in the very end of the book that you generally don't really hear a lot about, and we don't really pay attention to a lot, but they are really good things to pay attention to. And maybe some of the most important things about this code book are in the very front and the very end of it. Okay, so that's it for this video. If you enjoyed it, give it a thumbs up. Subscribe if you want to see more videos around the National Electrical Code Book, around being an electrician, electrical theory, electrical engineering. I'm going to have all sorts of videos around this, such as real on-the-job videos in the future, which will show you how to wire certain things and install certain things in a residential home. Until next time, take care and goodbye.